right, welcome everyone to this session. So this is Jason Shiverick, data platform manager at Rivian, and Vadivel Selvaraj, who's a staff software engineer. They're talking about Databricks as code, right? How to automate your Lakehouse using Terraform for resource provisioning. I guess with that, I'll let you take it.
All right. So today we're going to talk a little bit about Rivian. We're going to talk about some of the architecture that we use, and then dive into some examples for Databricks as code, i.e. Terraform, how we manage resources and provision our Lakehouse. I'm Jason Shiverick. I've been in the automotive industry working on vehicle data for a long time. I currently manage the data platform team for our Lakehouse. And introduce yourself, Vadivel.
And I'm Vadivel. I'm a staff engineer in the data platform team. I tend to focus on big data infra and also the data governance. Yeah.
Vadivel crushes it. A little bit about Rivian. If you missed the keynote, I think Wasim killed it. That was a super cool keynote, so I don't need to say a whole lot about Rivian. You should check that out. This color is awesome. From this picture, you can see that Rivians can go through rivers. That's really cool. Our products are pretty beloved by our customers and our employees. You can see in this picture we have a R1S and R1T. We also have a delivery vehicle, and we've won a lot of awards. If you haven't heard of our brand, it's a really great brand. I absolutely love these products. The mission of Rivian is to keep the world adventurous forever. So part of that mission is to develop products that people really love, that are sustainable, to bring people into our brand and expand that so that there's just less emissions. I think that's an awesome goal and one that we're very excited to be part of. A very important part of our mission is data. As Wasim kind of talked about, we have 32,000 cars on the road right now. We collect multiple terabytes of data per day, and we use that data to inform product design, do health monitoring on our fleet, and make sure that customers get the best experience out of our products as possible. And a big part of our data journey it has been the Databricks Lakehouse. Before we started with Databricks, we were running on EMR, but from day one we have been on Delta as a backend format for serializing data to, and it's been very powerful for us to kind of centralize and consolidate our ecosystem into a Delta Lake. It dramatically reduces the architectural complexity that we have to manage. I'll go through a short example of how we use data at Rivian. The top graph here is kind of a visualization of vehicle telemetry data. So we see a lot of telemetry data like torque and current. This is information that's very useful for engineers to understand the use cases and applications of our vehicles to help design better gears, better suspension systems, better batteries, and also enable us to monitor for anomalies and things that might be health-related on the vehicle. The bottom graphs are kind of what we do from that raw data. We typically aggregate the data using Spark on Databricks into cycle counts, other like deterministic, meaningful counting algorithms that drive health and behavior of the components on the vehicle. And then we collect data from service that helps us understand what components are failing at what rate. That gives us a survival function, and we can use that with like particle filters and common filters to do preventative maintenance models and prognostics. So that's a typical workflow for us, and so that telemetry data is core for us that we bring into our Lakehouse. We have automated over 95% of our Lakehouse, and we're currently running over 1,100 users on Databricks. The Lakehouse, like administrating Databricks, Databricks by itself makes it very easy to administrate with a relatively small team. And then the fact that we leverage Terraform to automate the provisioning of Databricks to increase reliability, observability of our platform, it's been very, very impactful for our ability to manage a very large platform with a relatively small team. From day one, when we first provisioned our workspaces, we used Terraform. The Databricks Terraform provider provisions our networking architecture, our AWS resources, and all of our Databricks ecosystem, as well as our jobs and schedules and runtimes. So how do we achieve petabyte scale in our data lake? This is kind of a basic architecture diagram of how we receive data, telemetry data from our vehicles. Basically, the data is uploaded to S3, and we consume that data in Kubernetes through a Go client that decodes packet capture files and converts them to Parquet, which as a time series makes the data available to our consumers. We're actually working with the Delta IO team and the Delta Rust team to implement a Delta connector for Go so that we can directly serialize those Parquet files to a Delta lake. And we're doing that at high scale, like about 10 to 20 terabytes per day, and many highly concurrent commits to the Delta log. From there, can you fix that? It's asking, oh, you gotta change your password.
It's about to get my passwords.
Well, you'll never, uh-oh.
All right.
Well, IT stuff is happening.
All right. I should restart my password. Just
There you
keep
go.
it
Oh
down.
man, that's fun. We have a logo now.
Yeah, that's a Compass logo.
We use the medallion architecture so for silver, bronze, silver, gold tables. All of that is exposed to our users on the Databricks platform, and managed, permissions models are managed by Unity Catalog. And all of that is configured and provisioned via Terraform. Oh man, the clicker doesn't work. Oop. There we go. Quick note about our Delta Go library. Like I said, we're working with the Delta team on this. We have open sourced this. It's currently in pretty heavy alpha stage, but we're using it for concurrent writes. This is what writing to Delta looks like with the low-level API, where you can create a table, create a transaction, and then create add insert actions on the Delta transaction log, and then commit those optimistically. So this is a very exciting project for us, and we're looking to build upon it, get developers involved. It's an open source project. So how do we manage jobs and resources? Our software development lifecycle looks a little bit like this. Typically, users on Databricks start with a notebook, and they build their algorithms or ETLs in a Databricks notebook. And once we want to go to production, we'll export that notebook as a Python file and co-locate it in a GitHub repository with the Terraform provisioning. And then the standard development workflow CI/CD kicks in, and once the code is merged to master, CI/CD provisions it to Terraform and deploys it to Databricks. And we'll start talking about Terraform now. So here's an example of a Databricks Job resource in Terraform. Useful things here that we are very happy with how we have configured this. The tags are very important for us. We use those for observability and cost controls and managing, allocating resources and cost centers to users. The schedule is basically a cron schedule that allows you to do task dependencies. We're very happy with just provisioning this schedule mechanism. We looked at using Airflow or other orchestration tools to manage our jobs, and this is just so easy and simple that we stuck with the basic scheduler in Databricks, which is getting more advanced all the time. Obviously, cluster provisioning is very important, being able to manage your compute resources. And one of the things I like a lot that we're heavily using is the GitHub source resource, which is basically a pointer to the Git repository. Rather than storing your source code in DBFS or S3, you can point directly to the latest version of master, and Databricks will automatically clone that repository and get your source control Python script. We're also leveraging the webhook failures for webhook notifications for observability. So we have a Slack integration that we use to tag on call anytime a job fails, and that makes it very simple. It integrates with PagerDuty. So this whole thing that we have set up with this Databricks Job resource has made it very easy to manage production level system. Next slide. So I'll hand it over to Vadivel, and he'll talk about some more really cool Terraform resources.
Cool. Thanks, Jason. Let's start with secrets management. So we manage secrets. We sort of provision our Databricks secrets using AWS Secret Store as sort of the key element. So the whole secrets management workflow looks like this. We have a user create their secret within the AWS Secret Store within an AWS account, and then they grant the Terraform provisioner the read access to read the secrets so that it can provision to Databricks. And then once we have the Terraform resource running, and when it does the apply, it's going to read the secret from the secret store and then create the Databricks secret scope. And we also manage the secrets access scope within Terraform as well. So that's the last part of the workflow. Cool. And this is how the Terraform code for that looks like. We start by reading the secrets manager. That's the data Terraform module at the first 3 lines. And then we define the secret scope. Here we are defining one to create Git credentials. And we declare 2 secrets within the Git credentials secret scope. One is to read the Python package, as an example here, which has a username and the corresponding token. There is also a JSON decode here that sort of decodes the output value from the data Terraform module and then infers the GitLab repo username secret from that. Cool. Another key part of our automation is how we enforce stacks, especially the resource stacks, which allow us to automate our cost controls, perform resource attribution. So this all starts with the Databricks cluster policy, which is sort of a policy that allows us to limit what a user can do when he creates a cluster. So, and these cluster policies can be created for different types of Databricks compute resources. It could be a personal compute, it could be an all-purpose interactive cluster, or it could be a job compute. So we define these cluster policies starting with the base cluster policy, and then we sort of merge these base policies with all the other compute policies. So this is an example here where we have defined 3 sort of mandatory tags, which goes into all of our Databricks resources. It starts with the job name, and then the job owner, which sort of helps us to map which team that specific owner belongs to, and then do cost controls. There is also an AWS Rivian cost center tag, which we use to associate all of our Databricks compute cost resources to that specific AWS cost resource center. So those are the 3 custom tags that we add for all of our jobs. And the last bottom resource defines this mergeable function, which merges the base cluster policy along with the personal compute policy that we have. Cool. So we have developed our own internal Python private package. It's called our PySpark utils, where we host all of our PySpark-related utility methods within it. So let's talk about how we sort of provision that using Terraform. So we use Databricks Init Scripts in order to aid with the package installation. This is an example script where it requires the GitLab package registry credentials. We pass the username and the token, and we can also specify which package version that the user needs to install in the cluster. And then if it's not provided, it's going to default to the latest version of the package by sort of querying the pip index utility. And this talks about how we sort of provision that using Terraform. We host all of our init scripts within the /shared/init scripts folder. And this is an example where we sort of where we copy our init scripts from our Git repository into the shared directory within the Databricks file system. And a quick tip, we are planning to use the Unity catalog volumes in the near future rather than using the Databricks file system for it. And this is an example cluster configuration of sort of how to install this init script across our clusters. This could be a job compute cluster, or it could be an all-purpose interactive cluster. So the key thing to note here is how we sort of pass our credentials using the Sparky and the VARs configuration. So if you see here, we have created the Databricks Git credentials secret scope, and we pass in the package reader username and package reader token to that init script. Cool. Next, I want to touch upon the how we sort of manage our Unity catalog permissions. On a cool start, we are the second largest Databricks customer in terms of UC usage. So let's look at how we manage the permissions. So it all starts with the Databricks user groups. So we sort of utilize the nested hierarchy structure of these Databricks user groups. So we sort of categorize into 3 different user groups. One is the team level user groups, where we group different users into teams. And then we have the functional tier user groups. So these functional tier groups are sort of exclusive to Rivian. We sort of categorize it based on the ownership tier. So we have 4 ownership tiers. One is the Rivian engineering tier, where we have the engineering vehicles. And then we have the external customer vehicles. And then we have some enterprise vehicles, which are the EDVs. And we also have an employee-owned tier. So these groups control access to these set of ownership tier vehicles. And then there's a third group, which is the database read and read-write groups. So all of our UC resource grants are sort of tied to these read and read-write groups. So this is the key component that sort of allowed us to scale our sort of permission model for all users. So in terms of the flow, we have the teams that are being tied either to the functional tier groups, or they can be tied to the individual database read and rewrite groups based on the access pattern that this team follows. So this is an example Terraform module that's being built in-house. And this will also be open sourced soon. And you can sort of watch out within our Rivian GitHub repo for that. We will make an announcement once that happens. So this example Terraform module ties users. So we have an user emails list that ties to the individual team user group that is part of. And it also defines what sort of access that this team can sort of get to within Databricks. And then the last one, we have the workspace access list, which sort of controls which workspaces within Databricks that these team can get access to. They can get either an administrator access or an user access. And this is all powered by the Unity Catalog Identity Federation, which sort of consolidate all of the users, groups, and also the service principals into the account level. and it also prevents prevents creating duplicates. That's one thing to note of. Cool. Another key thing that I want to touch upon is this Unity Catalog inheritance model. This is what that allowed us to simplify our inheritance. Simplify our permission model a bit. So this is an Unity Catalog object nested hierarchy. So you have the Unity Catalog metastore at the top with the storage credentials, external locations at the below. And then within catalog, you have the Unity Catalog schemas, and then you have tables, views, and functions. So in terms of the privileged inheritance, these are sort of downward inheritance. So meaning when you create an all privilege permission to an user at the schema level, all of the other objects that are within the schema will get access by sort of default. So that's the inheritance model. Let's look at how we implement that in Terraform. So this is an example Terraform resource config that allowed us to sort of map all of the UC objects. Like we saw in the earlier slide, we have the catalog, the corresponding storage credential, external location, the database name, tables, and views, and sort of how these tie into the read and read-write database groups that we talked about earlier. So so there are two sort of privilege grants that we do. One is the implicit, and the other one is the explicit. So these are defined by sort of how we define the tables and views arrays. When they are left empty, it means that all the tables and views within that respective schema will be granted read access to this read database group, and the read-write access to the corresponding read-write database group. And if we need to restrict certain tables within the schema, then we throw in those tables within this tables array, and that's how we are able to restrict certain tables. And this is the respective Terraform code that talks about how we grant access to database or these UC schemas. So we have two categories. One is the inherited and then the explicit category. So inherited will use the inherited privilege permissions, which include all privileges for the external location and database, whereas the explicit ones, they sort of go into the respective UC objects permission privileges. So the next slide talks about how we sort of manage the implicit and the explicit grants. So this example one ties into how we create the schema grants. So so this checks for the length of the tables array, and then based on that, it's gonna decide whether to do an implicit grant by sort of following the inheritance model, or it's going to use the explicit grants, again, based on the length of the tables array. Cool, that's all we have.